Welcome back. In this portion, we will be learning how to primarily make surface plots. The first part is that we actually have to go for the function. Inside the function, as we had done earlier, for a new function plot, if you look downwards, there are different options. One is a new 3D surface plot. If we go for a new 3D surface plot, we can automatically choose something of the sort of x square uh, plus y square. If we go for that kind of a function, and within this, and just click OK, that would give us a beautiful plot like this, and we could very easily animate that and see how it looks. You see, we could see how the thing evolves in this kind of situation. We can use this in the wireframe mode, which basically gives us how the plot would look just if we don't have the colors and all the things. And if supposedly we even hide the frames mode, it becomes much easier for us to view the how exactly the thing looks. Let's go back to this is one of the curves that we had actually um, uh, with all the equation and all this stuff written, so it's easier for us to understand how exactly that is done. We have another function over here. uh, let's stop the animation for now. If we have another function which is very pretty interesting, um, uh, which is sine x into cos y. If we look at the surface, we see it is sine x into cos y. We have taken the limits 0 to 2 pi, here also the limits 0 to 2 pi, and for this peaks to be easily visible, I have chosen the range from 0 to 1.2. So that basically gives us a kind of an understanding as to how the system works. So these two basically are very easy methods of seeing how a QTI plot works. Um, Now, if we supposedly, for the same curve, if we change the limits of the entire uh, uh, calculation for the x square plus y square from -1 to +1, we see that it -1 to +1 both for x-axis as well as for y-axis, and we allow it to auto scale for the z-axis. We see that actually this gives a much fuller curve, and we can see very easily that this basically gives a kind of a hump kind of a structure, which is very interesting to see how exactly the thing. We can close down the animation. Now we go for the next type of curve, which is a sphere. Now for that, what we have to go is the new 3D parametric surface plot. You see, in the 3D parametric surface plot, if you look at, now we have three options. One is the x, another is the y, another is the z. For the x, we basically could take sine of u star cos of v. We know that if u and v are considered to be sine theta and cos phi, then that should be the basic structure of this. This is taking the radius to be equal to 1. If we take a radius of equal to 1, then automatically that is what we get. Now we could take this as sine of u star sine of v, because if we look at the calculation of the entire, we find that it is sine theta as sine phi, sine theta into cos phi, sorry, sine theta into cos phi is what stands for the x component in the spherical polar coordinate system. Similarly, we have chosen the y coordinate for the spherical polar coordinate system, and similarly, when we go for this, we go for cos of v, and this would, sorry, cos of u, and that would basically give us the cos theta. And here we have to change the periodicity of phi, since v is this, so we have to change the periodicity of phi to 2 pi for this to become a sphere. And if we do it okay, what we get is a beautiful sphere over here, and we could use animation to show that this is actually a sphere of radius 1. So similarly, we have over here a sphere of radius 2. So we could easily create a sphere of radius 2, but by just, if you look at the equations, we see that we have multiplied this by 2. And so by multiplying all of them by 2, which is the r component, we can create a sphere of radius 2 similarly. We have shown in this portion that we can easily make a sphere using the 3D parametric surface plot, and we could make or draw complex circles. We could plot very complex circles, we could complex surfaces by using the new 3D surface plot in the QTI plot problem. So thank you very much.